So now we need to talk a little bit more about how we can calculate the probability of an event, right? We're going to do this both using the sample space, possible outcomes, as well as using data sets. So we know already, this is just a reinforcement here, when we calculate probability, it's got to stay between 0 and 1. So if you get, a fraction where the top number is bigger, like 5/4, you know it can't be right. If you get something that's negative, you know it can't be right. It's got to stay between 0 and 1, and mathematically, that could be written just like this. If the event cannot occur, if it's impossible, then the probability of that event is equal to 0. If it is certain to occur, then the probability of that event is equal to 1. Okay, these are just things to keep in your mind when you're calculating probability. So first thing we're going to talk about here is the situation where each outcome is equally likely. All right, where basically we think about a sample space, what could possibly happen, and the way we calculate probability is we take the number of outcomes included in event A and we just divide by the total. So if we use K to denote the number of outcomes for event A and N to denote the number of outcomes in the sample space, then what we're calculating for the probability is K over N. So let me just give you a very basic example, one that we've talked about a little bit already. Let's say we're rolling a single 6-sided die, and we want to know the probability that we get an odd number. Okay, we talked about this a little bit already, right? We know there are 6 outcomes in the sample space, and we can reference back right up here where we talked about it. We know the odd numbers include 3 outcomes in the sample space. And so to calculate the probability, we would just do 3 divided by 6. Simplified fraction, that's a probability of 1/2 or 0.5. All right, so example that we have here. In the Georgia Cash 4 lottery, a winning number between all zeros and all nines is chosen at random. What is the probability that the winning number is 1, 2, 3, 4? So obviously, this is a situation where we have a lot of possible outcomes. We don't want to try to list them out in a sample space like we could for the 6-sided die. What we can do, though, is think about the possibilities that could occur here. So if this is a 4-digit number, right, that means, think about, when those balls pop up, right, we've got something being selected for the first digit, the second, the third, and the fourth. And if each digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, that means it has 10 possibilities. So if there are 10 possibilities for each digit in this winning number, we can multiply those together to determine the total number of possible outcomes. If we were to list them all out, 0, 0, 0, 0, 0, 0, 0, 1, and so on. That total number of outcomes is always going to be on the bottom of my probability. And then the event, which in this case, I want to look at getting 1, 2, 3, 4, goes on the top. Now, when you think about your event, you're thinking about the possible outcomes that are included. And 1, 2, 3, 4 is only one possible outcome. So the probability that the winning number is 1, 2, 3, 4 is going to be that one outcome divided by the 10,000 total. All right, for part B, we want to look at a different event. We want to know the probability that all 4 digits are the same. Now that total number of outcomes is not going to change. We've already figured that out, right? There are 10,000 possible outcomes in the sample space. If all 4 digits are the same, right, think about what those would look like. And if we think about what the different options are here, right, we're going to have all the way up to 9999. In other words, there are going to be 10 possible numbers where all 4 digits are the same. And if I want to simplify this, that gives me a probability of 1 in 1,000. All right. I want you to try this one on your own first. You're going to be using the information from the previous example where we wrote the sample space. And so I'd like you to pause the video, try it yourself, see what you get, and then come back here and check with my solution. Now what I'm going to do is I'm going to come back up here where I looked at the possible outcomes. If a penny and a nickel are tossed, there are 4 possible outcomes. That is my total. So for any probability that I want to find, that total, that bottom number, is going to equal to 4. Part A, we want the probability that at least one will land on heads. We've got 4 total outcomes. The event that we're asked to look at here is what we did in part C. If at least one coin is heads, there's 3 different outcomes that are possible. And so the probability would be 3 out of 4. And just so you know, when you go through your homework in ALEKS, sometimes you're going to be asked to leave your answer as a fraction. So you type it in just like that. Other times you may be asked to enter it as a decimal, where you just go ahead, put it in your calculator and divide it. Or if you wanted to look at a percentage, you would just move that decimal 2 places to the right and you'd say there's a 75% chance. All right, what is the probability that no coin will land on heads? Well, again, we already know there's 4 possible outcomes. So we're just going to look back up here at our possibilities. There's only one outcome where no coin comes up heads. And so that would be a probability of 1/4, in decimal form 0.25, or a 25% chance.